Hi, welcome to part 11 of the video series about work and energy. In the previous video, we have solved some examples to see work energy theorem in action. In this video, we are going to solve one more example. A box of mass 20 kilograms starts from rest at a height h and slides down a rough slope of length 16 meters, which makes an angle of 30 degrees with the horizontal. It undergoes a constant acceleration of magnitude 2 meters per second square while sliding down the slope. Calculate the work done on the box by the frictional force using the work energy theorem. As usual, let's start solving the question by drawing a diagram. A box is sliding down an incline of a length of 16 meters, and angle of incline is 30 degrees. Acceleration of the box is 2 meters per second square. Now we can write down the formula of work energy theorem. Net work is equal to the change in the kinetic energy of the object. As a next step, we can draw the free body diagram to identify which forces are going to do a work on this object. As usual, force of gravity is acting downwards. The normal force is acting perpendicular to the surface, and friction force opposes the motion by acting up the incline. As we know, forces acting at a right angle to the displacement not doing a work, meaning we can ignore the normal force in our calculations. Therefore, work of friction plus work of gravity is equal to the final kinetic energy of the object minus initial kinetic energy of the object. Work of gravity can be written as mass times gravitational acceleration, which is equal to the force of gravity, multiplied by height of the incline and multiplied by the cosine of theta, the angle between force of gravity and vertical displacement of the box. On the other side, kinetic energy is equal to 1/2 times mass times square of the velocity of the box. Beside the work done by friction, there are two missing values in this question: height of the incline and the final velocity of the box at the bottom of the incline. To calculate height, we are going to use trigonometry. Side of a triangle opposing the angle, in this case the height of the incline, is equal to the hypotenuse of the triangle, which is displacement in this case, multiplied by sine of the angle of incline. 16 times sine 30 is equal to 8 meters. To calculate the final velocity of the box, we can use one of the equations of the motion. V final square is equal to V initial square plus 2 times acceleration times displacement. Initial velocity is equal to 0 as the object starts from rest. Acceleration is 2 meters per second square and the displacement of the box is 16 meters. Final velocity of the object is 8 meters per second. Let's continue the solution on a new page by writing down everything we know. Mass of the object is 20 kilograms. Gravitational acceleration is 9.8 meters per second square. Height of the incline is 8 meters. And theta is 0 degrees as the object is sliding down and force of gravity is also acting downwards. Final velocity of the object is 8 meters per second and initial velocity is 0 as it starts sliding from rest. Work done by friction force is negative 928 joules. In this video, we learned how to use work energy theorem on an object sliding on an inclined plane. In the next video, we are going to learn about conservative and non-conservative forces. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.